I'm looking.
This chart looks kind of hard. I'm not gonna lie to you.
It's not that bad. I'm going to show you how easy it is. No, it's actually grams. There's grams in there as well. All right, so real quick, gonna talk about the hardest part about what we're going to do today is that it is unfortunately named. The name of this process is stoichiometry. Stoichiometry is pretty much what chemists do. If you're talking to somebody and they say I'm a chemist, what they're talking about is they do this on a daily basis. Because what a chemist who works for Thermo Fisher in Greenville or DSM Pharmaceuticals in Greenville, what they do every day, if they're a chemist, is they look at these chemical formulas and they see, this is what I want to make. This is the chemical I want to make. Well, this is the reaction to make it. So this is the number, the amount of my reactant I need to make this thing, because you don't want to have to overbuy. Now, the bell ringer for today talked about making Big Macs, right? Okay, so let's make a Big Mac real quick.
I said 3, but then I replied to myself and it's messing around.
All right, well, let's look at what we have here. Okay, Big Mac is, bun, burger, bun, burger, bun. Okay, extra stuff in there. But for every Big Mac, it takes 3 buns plus 2 burgers to yield 1 Big Mac. Make sense?
Yep.
Okay, so all we're doing today is the math that comes out of this. If I want to make 6 Big Macs, what am I going to need?
You're gonna take 6 multiplied by 3 and 2.
Very good. Now, this is easy math. Sometimes in chemistry, we don't have easy math, and we need to write it down to be able to figure it out. And we're going to bring back our tool from the very beginning of the year. And so we're going to say, how many buns do we need to make 6 Big Macs? We're going to do the same thing that we did at the beginning of the year. You write down exactly what you want. We're going to draw our fraction. We don't want Big Macs. Where do they go? Those are buns. And we want buns.
So we want a burger.
So, well, whatever. You need buns. I'm just doing an example. Okay? Need 3 buns for every 1 Big Mac. So you're right, we multiply by 3. But this is a way to organize your thoughts. Okay? So 6 times 3 would be 18 buns for that many Big Macs. You could also do it to figure out how many burgers you would need for a certain number of buns. Okay? So how do we do this for a chemical formula? Let's go back to our chemical formula we used at the beginning of the year. Or the beginning of this unit. Hydrogen plus oxygen gives you 1. Now to start off, this does nothing for me. Why?
Because it's not balanced.
It's not balanced. So before you can answer any questions, that's why the top instructions on today's practice say balance then. You've got to have a balanced equation before you can do anything. 2 hydrogens, 2 hydrogens, 2 oxygen, 1 oxygen, 4 hydrogens, 4 hydrogens. Okay, same exact thing for this. The difference is, instead of talking about pieces, we go back to use that unit of measurement to see how much do you have, which is moles. Very good. So if I want 27 moles of water, how much hydrogen do I need?
You need
52.
Very good.
54, right?
Okay. No. Okay. So Martin nailed it, but let's do the math. 27 moles. Now we're adding one thing to this, because for the first time in chemistry, when we convert, we're converting from one thing into something completely different. So you're going to put moles of H2O.
What do I want to?
Well, it helps you. It guides you to go through this.
So 27 moles, you would have.
I don't want moles of H2O. Where are they going?
They're going to the bottom. So would you write it moles of H2O or just moles?
Moles of H2O.
Okay.
Because we're going from moles of one thing to moles of something different. Moles of H2 on top. Now, the only way you can change what you're talking about, going from H2O to H2, is to use the coefficient in the balanced chemical equation. How many coefficients we got there?
So 1.
And how many here?
Number 2.
Yep. And so we go back. 2 over 2 is
1.
1. So 27 times 1 is
27.
27 moles. So Martin was exactly right. You need 27 moles of hydrogen to make 27 moles of water. If it had been oxygen, we'll take 27 and do what to it?
Divided by 2.
Divided by 2. 27 divided by 2 is
13 and a half.
13 and a half moles of oxygen. Is it possible to have half a mole?
Yes.
Absolutely. It's not possible to have half an atom or half a molecule, but you can absolutely have half a mole. Now, if you remember back about the second chapter, if you have moles, what can you tell me?
6.02 something.
That can tell me atoms or molecules. What else?
You can learn grams as well.
Grams as well. And then I'm going to add one more to that,
Ounces.
which is this right here, not ounces,
Liters.
liters.
Big black box.
Yep, big black box. This is a mole box. Okay, this is the size of a mole if you have a gas. 22.4 liters in 1 mole. So I'm going to add one more thing to my island diagram. So let's remind ourselves about the island diagram. Mole,
Thermal.
and if you remember back, this one was grams or mass. This is atoms or molecules, particles. And this is volume. So to go from moles to particles, you already told me the magic number.
6.02 times 10 to the 24th.
Third.
22. 23rd. My bad.
To go from this one to this one, you get, look where? Where do we find mass?
Mass is
Grams.
In, where do we get the numbers?
One
I forgot what's the formula.
equals.
It's different for every single atom. So where do we look?
Oh yeah.
The mass on the periodic table.
The volume. Shelter house.
And then for volume, 1 mole is always going to be 22.4 liters.
Oh my.
Okay?
So 22.
So we got 2 magic numbers and then 1 that can be lots of different magic numbers. Okay? This is it. This is all there is to it. So let's make it hard.
Oh, why?
Why do I have to make it hard?
Yeah.
Because, let me rephrase. Let's make it more complicated. More complicated does not necessarily mean hard.
Okay.
You with me?
Why do we have to make it more complicated?
Because you're going to have to learn how to do this. All right, everybody good? All right, so I want to make 17 grams of water.
What?
I want to make 17 grams of water.
Yep.
Okay? And I want to know how many liters of oxygen I need to do that. Okay?
Hard scrap.
Always start with what you know.
You have
17 grams.
Put grams to
of
moles.
H2O.
Very good. Go ahead,
You
Martin.
have to do grams to moles, then moles to liters.
You skipped a step though.
What up, grams?
Okay? So grams to moles, I totally agree with. Grams on the bottom, grams of H2O on the bottom,
Yeah.
moles of H2O on the top. So let's knock this out.
Okay.
If I'm going to or from moles,
17 grams.
how many moles?
It's question one.
It's 1.
Every single
Every
mole
time-
transfer
every time
has how many
Every time
moles?
moles on the top, it's 1.
Well, don't say that.
Wait, what?
Every time, because we're about to change that.
Okay.
Every time you're going to or from moles from something different is 1.
Okay.
Okay? So 1 mole because we're coming from grams. H,
1.
how many do we have?
One.
One.
Yeah.
How many do we have?
1.
2.
2. So we have 2. And what about O?
15.9994.
AKA
16.
plus 2 is
18. Then we have to add 18, 19? What do we, wait, what do we,
You told me H was 2 because there's 2 of them.
Okay.
And there's one O is 16. 2 plus 16 is 18. Everybody good? If we stop there, we'd have moles of water. I don't want moles of water. Let's keep on rocking and rolling. This is the only thing that's different. I don't want moles of water. I put those on the bottom.
1 liter.
I do want liters, but I don't want liters of water.
You want liters of oxygen.
So I got to go from moles of water to what of oxygen?
Moles of oxygen.
Very good. Moles of oxygen. And these numbers come from your balanced chemical equation. So this is where you can have a different number.
You got 2 on. We have 1 for O2 and then 2 for H2.
Rock and roll.
So then it would be 1.
So it should be 0.5. Well,
1.
wait till you have your numbers, then do your math.
Yeah.
Okay. Then we're done with that. And we don't want moles. We want
liters.
so moles of oxygen on the bottom, liters of oxygen on the top. How many moles?
1.
And how many liters of oxygen, no matter what?
22.4.
Oh,
How many
yeah.
liters of anything? All right. We got to math it up. To do this math, what are we going to do?
We're going to multiply across the top and the bottom.
Multiply across the top, multiply across the bottom, and then
So it's simplified.
multiply across the top, multiply across the bottom, and then
Divide.
divide. So we're going to get your told you to get your calculators. Everybody ready?
So it's going to be 22.4 divided
Nope,
by.
slow down. Because we got 17 on top. 17 times 22.4.
380.8.
Who cares?
380.8.
And then divided by what? Don't say 18.
8. No, you have to.
It's going to be 17 times 18.
17's on top. 17's not on the bottom.
It's going to be 36.
You everybody good with that? You understand what I mean? Like 17 is on.
Yeah, there's nothing.
17 is just on the bottom, on the top. Ah, shit.
Oh, we heard that.
I don't care.
It'll be okay.
Yeah, like we say words.
Everybody good?
Yes.
17 times 22.4. Smash the enter button. Divided by 36. Give me an answer.
17 times 24 divided by 30.
22.4.
What is wrong with my calculator?
Why are you screwing things up, man?
36. Is 10.5777777778. So 11.
Give me a little bit. That's enough.
Okay.
You get tired of playing times?
That's actually not that bad.
That's as hard as it gets.
That's not that bad.
That's as hard as it gets.
I mean, you're the tired, so it'll kick you.
I hear you, buddy. One more try. One more example.
Yeah, sure.
All right, let's do number 4 on your practice.
I'm on the way to practice.
I'll help you out a little bit.
Let me load it up.
So we got NH4, NO3. Is going to break down to N2O
Oh, what?
and H2O. What type of reaction first?
It's going to be a double replacement.
Ooh,
Was it single?
ooh.
Neither.
Was it?
Got how many things on the left?
2?
No,
No,
there's
there's
4. And there's only 3 on the other.
How many things on the left?
N, and then, there's 3.
No, 1.
There's 2. What?
That's ammonium nitrate. One thing. Ammonium nitrate. Why is it only one thing? There's
It's
no
not
in
plus.
parentheses.
I'm stupid.
It ain't in parentheses.
There ain't no, well, even if there was a parentheses, there's
There's no
no
plus.
plus sign.
There's no plus sign.
We got one thing breaking into 2.
It's going to be synthesis.
All the way
No,
around.
no. Decomposition.
Decomposition. All right. 2
Where-
N's, 2 N's,
Where-
4 H's, 2 H's,
Where-
So 2 and then.
3 oxygens, 3 oxygens.
Yep.
We can tie line 5, right?
Yep.
Okay. So let's look at the question. This is what I always do whenever I have a word question. I always write this on my paper. How many grams of water? Let's go ahead and write that down. How many grams? That way you know exactly where you're going. And I read the wrong one. My bad. Sorry, I was reading number 5.
It is
How many grams of NH4NO3 are required to produce 33 grams of N2O? And they even cheated. They give you a little molar mass down there. Okay. Start off with what you know. 33 grams.
Yep. And we
All
want
right,
to
make sure we put N2O. Give yourself plenty of room.
Okay, I have a question.
What's up?
If we're trying to get grams, but we're already in grams, then why would we? I'm confused.
Because what do you have grams of right now?
NH4NO3.
No, you don't.
Yeah, we did.
Actually, no, you have them into
Right. And what do you want?
you want NH4NO3.
So do you have grams of the same thing?
No.
Those things are going to change. Okay.
Okay.
So I don't want grams of N2O, so I'm putting them on the bottom. I'm going to change that to what?
Grams of NH4NO3.
Can't go straight from grams of this to grams of that.
Grams of moles.
Grams to mole. N2O. How many grams of N?
33. Actually, well, I don't see it.
How many grams of N? Help out, Martin.
14.
14. Well, we got two of them.
28.
28 plus O is
28 plus 16.
28 plus 16. Calculator if you need it.
42.
38, 44, right?
44.
Yeah. I did. I said 44.
No problem.
Wait, so where do we get 16 from?
O is 16.
Okay, got it.
No problem. Moles of N2O on the bottom. Moles of blah, blah, blah on top.
No.
Moles of whatever that is up there.
It's something. It's ammonium nitrate.
Well, that's the reason I just blah, blah, blah it is what's my ratio?
It don't matter.
No, it does matter.
When?
What numbers are here?
And
What numbers are here?
one.
Very good. That makes for easy math, right?
E.
Okay. I don't want moles, I want
Grams.
grams. And it even gives you grams on a little paper there if you're doing it. You can math it up if you wanted to. You would say 14 plus 4 plus 14 plus 16 times 3. You add it all up. Mr. Sleepy did it for you because he's a nice guy. 60 grams. Math here.
So it's gonna be 33 times 60 divided by 44.
Boom.
My calculator is free.
Feel free to trade it out, man.
It's like it won't type half.
You got one of those cool ones, right?
Yes.
Mr. Sleepy grabbed one. But you can trade it out later.
I got it. 45 is the answer.
You agree with what I'm saying?
Yes.
Did you do it?
If it's a calculator.
Did you do it?
No.
Try it,
I'm
man.
listening.
Make sure you agree with him.
It's 45 on the dot.
45 grams of the blah, blah, blah. See, does it make sense? It's a 1-to-1 ratio. You expect it to be pretty close because it's a 1-to-1 ratio. The reason this number is higher is because there's more crap there. You understand? A mole of this is going to weigh more than a mole of that. There's more stuff there. Questions? All right, guys, if you got any questions, shoot me an email, things like that. Do your practice. I will probably respond to your practice, but paper, taking pictures of it is the easiest way to do this practice. This is your last, the practice over the next couple of days are going to be your last grades on this 6 weeks. Let's make sure we knock it out. Go back and take care of any zeros. This test is going to be on the next 6 weeks. Y'all have a great day.
You're good.